Alright, so we're asked to select the correct graph of f of x equals square root of x. So we have f of x equals square root of x, which of course is the same thing as y equals square root of x. In order to graph this function, if let's suppose that we don't know anything about this function, we could find some points, some ordered pair solutions by substituting values of x. Notice the domain of this function, the smallest number I can insert for x and get a real number answer out is 0. And I can plug in any positive numbers. I couldn't plug a negative number in and stay in the real number system, so the domain is 0 to infinity. That is, I can plug in any number I want from 0 to infinity. If I put 0 in for x, I would get 0 for y. If I were to put 1 in for x, the square root of 1 is 1. We could plug 2 in, but then we would get square root of 2. Probably 4 is the next nice number to plug in, because square root of 4 would give us 2 for y. And if we sketch this, so we have 0, 0, 1, 1, and 4, 2. The next solution would be, if I plug 9 in for x, I would get 3 for y. It'd be like out here somewhere. And so here's the graph. And you notice that corresponds to graph B. The first graph, graph A, that's the function absolute. That's f of x equals absolute value of x. This is the graph C is the identity function, f of x equals x. And the last one is the square function, f of x equals x squared. So all these functions are in the library of functions. Is this function an even function? Well, an even function means that it's symmetrical with the y-axis. So an even function is always symmetrical with respect to the y-axis. And this graph is not symmetrical with respect to the y-axis. Now, graph D over here, graph D is an even function. Notice that the graph of f of x equals x squared is symmetrical with the y-axis. We see the same thing on both sides of the y-axis. So the square function, graph D, that would be an example of an even function. The absolute value function is also an even function. Once again, notice that it's symmetrical with the y-axis. And just to mention, an odd function means that it's symmetrical with respect to the origin. The identity function is actually an odd function. Notice that we see the same thing in quadrant 1 as I do in quadrant 3. That's symmetry with respect to the origin. But the square root function, the function in question, is neither even nor odd. Is the function increasing on the interval negative infinity to infinity? Well, if we look at this function, down here that we graphed, notice that the function is always increasing. It's always going up. But it's increasing from 0 to infinity. The question is it increasing from negative infinity to infinity? Well, the thing is, the function doesn't even exist to the left of 0, so we can't say it's increasing from negative infinity to 0. It doesn't even exist over there. So the answer is no. If the question was this, is the function increasing on the interval 0 to infinity, then we would have yes. The function indeed is increasing on 0 to infinity. The last question is the domain negative infinity to infinity? No. We established the domain over here at 0 to infinity.